As I said earlier, I'm Mike McKay. I'm the president of the Skeptical Society. And my talk today is on time-traveling porn. Fact or fantasy? Now, I'm going to explain what that is, so don't worry. Now, what is time-traveling porn? Time-traveling porn was a term used to describe some of the research that Daryl Bem has done. And Daryl Bem is a psychologist. He published an article in 2011 that discussed 9 experiments he did. And I won't have time to describe all of them in detail, but I'm going to describe one of them. Experiment 1, he had 100 subjects doing 36 sessions. Now, in each session, he had someone sit in front of a computer screen. They were shown 2 curtains, and they chose one of the curtains. And then if they chose the right curtain, they'd see a picture of hardcore pornography. Otherwise, they'd see a picture of a wall. And what happened behind the scenes is that once they chose one of the curtains, a random number generator placed a picture of porn and a picture of the wall behind one of the curtains. So, and then they were shown whichever image they chose. So, what he found is that people picked the curtain that ended up having the porn 53.1% of the time, which is pretty incredible, because that means, if this study is correct, that people have this sort of extrasensory pornception, that they're able to somehow predict where the future porn will be, or that the porn travels from the future and infects their brain, or they're able to see into the future and somehow retroactively know where that porn will be. So this is pretty incredible. We think of causality as us doing something now causes something in the future. Well, this would totally change all of that. He also asked the people some various questions. And he asked them whether they're easily bored and whether they tend to rewatch movies. And he came up with his own measure for whether people are easily bored and whether they don't rewatch movies. And so those who are easily bored, don't rewatch movies, he called those stimulus seekers. And he found that stimulus seekers picked the porn correctly 57.6% of the time. This is pretty incredible stuff. Now, why do I care? First of all, it's a serious study on time-traveling porn. What's not hello? And second of all, it would be totally revolutionary if true. I mean, it would totally change what we think we know about how the brain works. We'd have to try to discover what kind of psychological mechanism is there that allows us to see into the future. It would change what we think we know about physics and philosophy, how causality works. So it would be a completely revolutionary finding, true. And last, one other reason I want to talk about it today has to do with a cold reading workshop we did a while ago. And there was a woman, actually a massage therapist that Alice knows, who came and asked a question about this study. And there's another skeptic who responded to it kind of dismissively. And he didn't really know the study and was just, dismissing it like you might, casually dismiss a lot of stuff. And I think that was a mistake. I think, it's people believe these things for serious reasons. And there are reasons for people to believe this study. And I think we should try to understand, what's really going on and make sure we're not too dismissive. If it seems like we don't know what we're talking about and we're dismissive, it can really tune us out. Now, what are some reasons people might have for believing this study? Well, this study actually has some qualities that a lot of these studies into weird phenomena don't have. So I'm going to talk about some of the things that you might use when trying to evaluate a study and show how some of these actually hold for this study, how it doesn't fall victim to some of the problems other studies do. First of all, it's a randomized experiment, which is good for statistical purposes. It was also based on a lot of common psychological studies. It just reversed the the order in which things were done, so it's, well-established stuff, not just stuff you made up. And it had very significant results. The 57.6% I said earlier had a p-value of 0.00002, which means p-values are basically how, if there's no effect at all, how likely these results are. So this is a very surprising result if people can't see into the future and see the point in the future. And if you combine all 9 experiments together, you get an even better p-value. It's also by a well-respected Cornell professor. It's not just some random guy no one's ever heard of, or some guy in Nigeria researching some kind of quack medical treatment. And it's also published in a top social psychology journal with a high impact factor. So impact factor is a good way of assessing journals. So basically what it means is that if there's a journal that has articles that a lot of people are citing, that other researchers read and use in their own research, it has a high impact factor. There are some journals that have articles pretty much no one ever reads or cites. That's, just people want to get stuff published. So it's important to look at that because the criteria for acceptance is a lot lower on these low impact factor journals. But this is one of the highest impact factor journals. And also, the results he found were pretty substantively significant. Now, it wasn't, ridiculous. It wasn't like 100% of the people could see the porn, but it's significant enough because how to become fabulously wealthy. If his study is correct, there is a blueprint for how you can become wealthy. Now, there actually is stuff you can put in that question mark in step 2. So here's my thinking. You bring a stack of hardcore pornography to a casino. Now, you gamble on red or black on the roulette wheel. If you guess right, show yourself a photo of hardcore pornography. If not, don't. Now, if this study works, the porn you see goes back in time to induce you to pick the option that will cause you to see the porn. So, if you're a stimulus seeker, and so you would get this right 57.6% of the time, even after the casino's cut, you can get an average of 10% of what you bet on every spin. So if you bet $1 on average, you'll get $1.10. So very quickly, you can make millions, or even billions of dollars. So if you don't believe me, and you think his research is legit, test it for yourselves. Yeah. Let's talk about some reasons for being skeptical of this study. Now, first of all, I'd like to say that what we don't want to do is say, this seems like a silly study. Let me try to figure out the reasons why it's wrong. We shouldn't assume something is wrong. Even if it seems very unlikely, it's possible occasionally that it's not the study that's wrong. It's our initial assumptions and guesses that are wrong. Because I wager that pretty much everyone here has some things they believe that aren't actually true. So, we want to be skeptical, but we want to be fair-minded in how we do this. First, I would like to talk about the difference between exploratory and confirmatory research. Now, here is a comic, XKCD. If you don't read it, you should. It's really funny. And here are 2 people. And one person proposes that jelly beans cause acne. And so they decide to go and test it. They find no correlation between the 2. So someone else proposes, hey, I heard it's only one color of jelly bean that causes that. So they test 20 different colors of jelly beans. And they find, hey, we get a p-value of 0.05 for the green jelly beans. Now, what that means is if green jelly beans have no effect, we'd expect those results 1 out of 20 times. Well, we ran 20 different studies. So even if jelly beans have nothing to do with acne, which I think is probably the case, we would, on average, get one of these results. So what we don't want to do is say, breaking news, jelly beans cause acne. So one thing that's important to note is that a few of these 9 experiments were exploratory research. So that means, he was testing a bunch of different stuff, testing different hypotheses, different models. And so treating that as confirmatory research is a bad idea. What you want to do is have one hypothesis, make clear this is what my experiment is, this is what I'm testing, and then see what the evidence holds, He also, for these exploratory studies, I'm not going to talk too much about this, but he did a one-tail p-test instead of a two-tail, and you can look that up on your own, but it's basically, if you don't know which direction the effect will be, you want to use a two-tail. Now, one problem with Daryl Bem's research is his attitude towards research. Now these are some quotes he wrote in something instructing other psychologists how to do their research. He says, the conventional view of the research process is that we first derive a set of hypotheses from a theory, design and conduct a study to test these hypotheses, but that this is not how our enterprise actually proceeds. You should analyze the sexes separately, make up new composite indices. If there are subjects you don't like, or trials, observers, or interviewers who gave you anomalous results, drop them temporarily. Go on a fishing expedition for something, anything interesting. Now, the problem is, I kind of explained some of the reasons I think this is problematic, but the issue is not with Daryl Bem. This is something that is this attitude is very common in social science research. And so I don't think you can pick on just Bem. I mean, this is how people often publish. They collect data, they try out a bunch of different models and see, where the correlation seems to be. But if you test models, 20 different ways, then if you get one significant result, that doesn't really tell you that much. Now, what are some of the reasons that the studies that get published could have a bias? Now, I've already talked about some of them. You can choose a bunch of different models. There's also something called optional stopping, which is when you collect a little data. If you have significant results, you stop. If you don't yet, you collect more data. You can also combine 2 different studies that have insignificant results together to try to get one significant result. And looking at his research, it seems like he has done some of this. And actually, in one panel discussion, he specifically says that there was one that he stopped after 50 because he had significant results. And it was the end of the semester, so he didn't bother doing what he had originally planned. And if you also look at the effect size for these studies, you can see that there is some manipulation. Because if you do studies of different sample sizes, you'd expect that as you get more and more people in your sample, it would converge on the true value. So if you do a study of hundreds and hundreds of people, you get something more accurate. Well, what his studies show is that as he got more and more people, the effect diminished more and more. So that kind of shows that there was some experimental manipulation going on of some sort. And there's some other problems, some reasons that published studies can be biased. Experimenters choose what to publish and whether to publish. So if someone doesn't get significant results for a study or part of a study, they're much less likely to publish it. It's called the file drawer effect. They just don't even bother trying to publish it. And one reason for that is journals are very unlikely to publish negative results. They want exciting new findings. So they're not as likely to publish something if it's pretty consistent with what everyone already thinks. It's not news. They want news. And people, for their jobs, have to publish or perish. So it's important to do studies that journals want to pick up. So there is this incentive to do the kind of stuff Bem does. So I think we need to not just criticize Bem, but we need to look at how the social sciences work and how the publication process works and try to improve that. Now let's get Bayesian. Now, I don't know how many of you know about Bayesian probability. I think it's very unlikely that I can explain it adequately in just a few minutes, but I'm going to try to touch on it a little bit. One way of thinking of it is just extraordinary claims require extraordinary evidence. So if someone makes a claim that contradicts all the prior evidence we have about the way the world works, we want a lot of evidence in order to change our mind. Now, what that doesn't mean is we say, well, this just seems weird to me, therefore it's incredibly unlikely. We want to look at what our past experience tells us. Now, up there is Bayes' rule on a shirt. I don't know if you can see it, but let's look at it from an example. Let's say, great news, you just find out that you won the lottery. Now, you're trying to find out, I don't know why, I just probably, cashed the check as soon as I could, but you're trying to find out if someone rigged the lottery in your favor, just you, like someone you don't know for some reason said, I wish this person won the lottery, I'm gonna rig it in their favor. So on the left side, what you're trying to find out is the probability of someone rigging it. Someone rigging it will be A, given that you won, which will be B. So you want to find out, you know you won, what's the likelihood someone rigged it? So you can just plug stuff into this equation. Now, probability of A there on the right is the probability that someone would try to rig the lottery in your specific favor. So you want to see how likely it is that someone tried to rig the lottery. So that seems pretty unlikely. I would say that since I think most lottery winners won fair and square rather than due to someone somehow winning the lottery, I think, and it's also very unlikely that they would choose you rather than themselves. If you figure out how to rig a lottery, you're going to rig it for yourselves. So I would say that is far, far less likely, maybe millions or billions of times less likely than the probability that you actually win the lottery fair and square. The probability that you win the lottery fair and square is probability of B down there. And probability of B given A is the probability that you win the lottery B given that someone tried to rig it in your favor, which is A. And we can, look at some different values for that. But let's say maybe it's 50-50. There's a good chance that they'll get caught. I mean, maybe it's far less than 50-50. I don't really know. Maybe we need to determine exactly what we mean by try to rig it, how serious of efforts do we count. But anyway, if you multiply up to 2, 1/2 times some ridiculously small number divided by something slightly less ridiculously small, maybe a million times less ridiculously small, you get something that's very, very small. So as I said, the probability of someone winning the lottery in your favor is far less likely than the probability of winning the lottery fair and square, or probability of winning the lottery in general, which is P of B. So anyway, you end up with the value being very, very small that someone rigged it in your favor. So I don't know if all of you were able to follow that. I'm sorry. You can see me later if you want more of an explanation. But basically, what we're doing here is we're comparing two different hypotheses. And what you don't want to do is just say, well, the probability that I won the lottery is so incredibly small, there must be another explanation. Well, no. I mean, some people do win the lottery fair and square. It's unlikely. But how likely is it compared to the alternative explanation? So a Bayesian approach looks at the likelihood of the different explanations being true. And it also takes into account the prior evidence, the prior probability of something being true. If you have a lot of evidence that something won't happen or is very unlikely to happen, then you have to have a lot more evidence to shift that. I think gravity is very well established. It would take quite a lot of evidence to convince someone that instead of 9.8 meters per second, it's 4.3. It would take a just incredibly ridiculous amount of evidence to do that. Now, some people have looked at Bem's research from a Bayesian perspective. And what they found is that his results kind of disappeared. When you compare it to the alternative explanations, it becomes much less likely. For one thing, I think the prior probability is very, very small. I think we have good reasons based on all of our experiences in the world to say that the likelihood is very, very small that people can see porn in the future. But also, the change in that ends up being very, very small. So it's not just that our prior belief is very small, but the degree to which this evidence should change our belief is also small. And I could get into a lot more detail. Bem responds to this by saying, well, if my prior guess is that, so basically, I would say if this kind of effect exists, we don't know how strong it is. Maybe it's similar to the average effect size in other psychological studies, but we don't really know. Are people are these sensation seekers almost always right? Or, how likely? I'd say I don't really know. But what Bem did is he said, he compared the hypothesis that there's no effect to the hypothesis that if this is true, he'd get exactly the result he ended up getting. That's a bit of a simplification, but basically that's what it is. He got some significant Bayesian results when he made a lot of unrealistic assumptions. But when there were other Bayesian analysis, they didn't find significant findings. Now, this is probably a lot for you to make sense of. So, what I think we need to do when we get different ways of assessing data giving us different conclusions, is we need to see whether these results can actually be confirmed. So there have been some applications. Richard Wiseman and a few other people have done 3 studies where they all failed to replicate Bem's findings. And this was published in a really well-respected journal, Public Library of Science. And there's a forthcoming article where Jeff Galick and others studied over 3,000 people and found no results. They also analyzed all these different studies, including a couple people who haven't published anything but say they have significant results, say they've been able to replicate. And replicating basically means doing the same thing Bem did and seeing whether you get the same results. So there have been a couple people claiming success, but overall, there's very bad confirmation. So for these reasons, I don't think we have good reason to believe that there's such a thing as time travel porn. And so because of that, I think we can only dream what porn the future will bring. Thank you.
So, when you're doing the Bayesian analysis, obviously you have to make up a number for probability that we can see in the future. So, if you're just making a number, how does that work from dismissing the odd end?
Because when you have a specific number and see the implications of that, you can give reasons for that number, and then people can dispute that number. So there are other reasons in favor of Bayesian look, but I think one of them is you lay all your cards on the table. People can have disputes, people can disagree, and sometimes you just have to try to replicate it. But I think it's important to lay your assumptions on the table. Anyone else? Yes.
I have to ask, did you try this porn at the casinos?
I have not. So I'll leave that as an exercise for you.